Hello Year 12 and welcome to our first ever video, I imagine. Now this is for our new topic, correlation and regression. It's a data and statistics topic and we're looking at a new type of data here. Right, we're talking about this thing called bivariate data, which is where we have data with two separate attributes. Right, and I think the best way to explain that is going to be with an example later on, but let's have a look now at this idea of the patterns that can be formed. Essentially, we get a pair of coordinates for every data point, and so we throw them on a number plane and we might observe some sort of pattern. Now here, if we can see my pointer here, no sort of discernible pattern, but we have a linear pattern here. There is some sort of pattern here, it would seem, like a horseshoe shape, but it's not a linear pattern, it's not a straight line. This is not enough to suggest that there is a linear pattern because of this gap in the middle, so we would say there is some clustering going on there, but not necessarily a linear pattern. This maybe has some sort of linear pattern with some outliers, not enough really to describe these as a separate cluster, just outliers perhaps, and this is a linear pattern too. However, you'll notice that instead of sort of going up like this, it's going down as we go from left to the right. Righto. Linear patterns, if we look at it, we could say, right, if we observe a linear pattern like these two, I would say that this has a positive association, just like a positive gradient goes up from left to right, and this has a negative association. Now the strength of this association as well is not related to the steepness of the line. Right? The strength of the association is how well they conform, how well they all fit together to form a nice neat line. Okay, so we might say this is quite a strong association. It's negative because it's going down. Its strength is not in the steepness, but in how neatly they form a straight line. I can't observe a pattern here, whether it's going up or down. Here I observe a positive association and a very clear one as well, right? If they fall in a perfect line, we call that a perfect association. Right. Now we can use bivariate data to examine all sorts of things. One of the things we're going to look at is this thing called biometric data, which just means bio meaning like life, metric being to measure. That we're going to look at things like body measurements, whether that's the lengths of different bones, arms and legs, or height and weight, whatever that is. We will look at some of those sorts of measurements and see if we can observe an association. So here we go, we have an example here, and I have 10 male swimmers. I have their height and their arm span. Okay, both measured in centimetres. We need to plot this data here on a scatter plot. Now I have drawn a bit of a graph here, and I would like you to draw this up on your notes as we go along as well. Now having a bit of a look, we need to do it as neatly as we can. My smallest height is somewhere in the 180s, and my greatest doesn't beat 200. My arm spans range from 180s to 200 and something, so I think that, right, again, remember that we would normally put the top row across the bottom, right, going horizontally. So I think we'll make sure that this goes from about 180. I'm going to go from here, that'll do me. 180, how about we call this 1, 2, 3, 4, 5, 185, 190, 195. Have I gone too far there? No, just here. 195 there. 200. No, too short. 200, and so on. That's going to be my horizontal axis. And so this is going to be my height. In centimetres, we said that was 180. 190, 200, and I think the same thing going up, 3, 5, and I think we'll start at 180 again too. 3, 5, What am I after here? That's 180, 190, 200. I can go up a bit further. Should have arrows on the end, and this is going to be my arm span. Now, it's a bit silly to suggest that one of these is dependent and the other is independent. The one depends on the other, but where we have a table, right, a table of values like this, the top one we would tend to class as the independent, and that goes on the horizontal axis. Arm span, which is going to be S in centimetres. Not as neat as it could be, I'm afraid, but that's what happens when you're working with stylus. Now we need to plot this data. So 190 across, or 92 up. 190, 192. There's my first data point. Now you'll notice they're not necessarily in any order, but it is important. I can't just do all of these numbers and then just match these up at random, right? They do have to be tied together, just like coordinates. So now 192, 194. I think that must be just here. 192, 194, 199, 202. 199, 202. Oh, what happened there? I've dropped the one a little bit. There it goes. 199, 202. 188, 189. 188, 189. Now you can see a pattern developing. Right, maybe not perfect, but getting there. 197, 200. 197, 200. There we go. 187, 188. 187, 188. 194, 196. 196. There we go. That's a pretty strong correlation here. 198, 202. No, oops, doesn't matter. 198, 202, just here. Not perfect though, you see, that we've got those ones side by side. 193, 197, 193. What's that? 195, 67. And 199, 200. Okay. So we certainly have a very strong positive correlation there, right? That's what I'm going to say. Describe the pattern. Very strong positive, not very positive, right? Very strong, meaning a straight line. Very strong positive correlation. We could say association. I'm going to say correlation. I think that's fine to say that. Is the relationship strong, moderate, or weak? Oh, sorry. Well, this is positive. I would say it's very strong. Goes down here. Should read the questions that I wrote before I answer them. But anyway, comment on the statement. For a male swimmer, arm span and height are approximately the same. Yes. This statement is supported generally. Supported by the data. That'll do. Not a great answer, but frankly, not a great question. Rightio, that's our first video. We've learned a little bit here about correlation, what that means. We've learned a little bit about bivariate data, so that's data with two attributes, right, which we plot like coordinates, like x and y values onto a number plane. A trend that forms a straight line is a linear association. If it's going up, it's positive. If it's going down, it's negative. If it forms fairly neatly into a line, it's fairly strong. If it forms a perfect line, well, it is a perfect correlation. Okay, that's it for the video. I'll see you in class.